Hello everybody, welcome back to another episode of Want Less Object. This is going to be the video that I was telling everybody I was going to put out about all the modifications that I've done to the Super Pro modified cheapo wood lathe. So let's just get right into it. I'm going to make this a quick video. Just, for some information, maybe there's somebody else out there that is interested in doing the same thing. And so, okay, here we go. So let's start with the motor, the original stock motor. All right, this is the original stock motor that came with the machine. Well, let's turn it over so we can read it. I don't know if everybody can read that tag or not, but, let's just say it's okay for some spindle work, but you're not going to do anything major with this particular motor. So that was the first thing that I did to the machine. Took that motor out and I swapped it for a bigger motor. This is the motor that I swapped it for. This particular motor came out of a Treadmill. Those are readily available. You can find them all day long. I don't know, eBay, Facebook Marketplace, side of the road, people giving them away, charging money, people, whatever. But this motor that comes in there, it's actually, honestly, it's quite a valuable item, because there's so many different things that you can do with it. When people buy them treadmills because it's a great idea, and then they get bored with it, or they realize that it's just hogging up too much space, or they're tired of looking at it and they get rid of it. So I am a collector of sorts of treadmills because I use the parts in them. So this motor came out of a Treadmill, like I say, and it's a 2.65 horsepower motor, but it's only a 1.5 constant horsepower motor. So I had this motor and the motor that I've now have in the machine. I got those both basically at the same time. I went with the smaller motor because the faceplate on it was more easily adaptable to the original stock setting location of the factory motor. That's the only reason why I use this motor. So you can see that I had to do a little bit of machine work on the flange on the motor to get it to clear where it needed to be. This is the bracket that came with the factory setup, and it gets bolted into place in basically that sort of fashion. And you could put it, at that time, you could put it back in its factory location, right up underneath the machine, and everything was good to go. You didn't have to do any major modifications. I ran the machine like that for a couple years, and it worked great. I was happy with it. Then I started to have problems with it, and I put a video out, and in the video, you got to see this motor burn up. The bearings seized up in this motor, and I think it's because it got so impacted with wood chips and dust. Now, you probably can't see it in the video, but it's in there. You can see it, physically see it. It's all down inside of there, and it caused a lot of problems. It caused the motor to seize up. Oh, there it goes. I can spin it, but it's really bad. So anyway, so once that motor burnt up, I decided it was time to put the bigger motor that I had into this machine. I knew that motor wouldn't fit well in the stock factory location. So I knew I had to do something else with it. But I don't like the motors that people mount on the back of the machine or on the back of the machine. I don't like the look of that. But to each his own on that. I like a nice clean look. So, I mounted that motor underneath the workbench. I had to make new pulleys. Pulley on the motor, pulley on the headstock. Took a little bit of time to find a belt, the right width and length that I needed, but they're out there, you can find them. And they're not that expensive, you know, under $20. Amazon type deal. So, there is now a 2 1/4 constant duty permanent magnet DC motor on this machine. Like I said, I've got it mounted under the bench, and I guess I can show you. The camera view is going to get a little shaky jiggly because I'm going to take it off the tripod. So let's have a look at that real quick. There's the motor. You're not going to be able to, well, I guess you could read the tag, but it's upside down in its current configuration. This is the new pulley that I made, and basically all that is, it's the flywheel that came with the treadmill that was already mounted to this machine, but I machined it back and removed all of the mass and the weight that was out here, and then let's see if I set screwed it here, and there's another set screw 180 degrees there to lock it in place so that I could run reverse and I wouldn't have to worry about this screwing off because it's a thread-on type flywheel. You can also see the belt that I purchased to put on here. It's 43 inches usable length. Anyway, moving on. The belt, everything goes under the machine. So this comes up through the bottom of the machine, goes up inside, up through the headstock, and we take this cover off. And here you can see, it's kind of weird doing this camera. So there's the other pulley that I made. Basically, that was another pulley that was inside of a treadmill, and I had to machine a bushing to go inside of it that fit the spindle of the lathe. So that's also set screwed. There's a groove that runs across this shaft in this headstock, and then that set screw runs down and locks this pulley in place to the shaft. And it works great. So here's the back view of the machine. This is the other cover. And in there's access to the, well, you can't really, there it goes. In there's more access to the pulley. So far, we got the motor, we got the pulleys, and we got the belt. So this, let me put you guys back on the tripod. See if I can get this. All right, that'll have to be okay. This is the original belt that came with the machine. It's only about 3/8 of an inch wide, and it's a groove belt, and it goes with these original pulleys. These are step pulleys. They're made out of steel. There's a set screw in there to lock it onto the shaft. This one is the one that was on the original motor. It's also, I also remachined the bore so that it would fit that 1.5 horse motor that I put on there. and it worked great. I never changed the pulley location because I didn't have to, because I put a variable speed drive on it. This is the original pulley that came off the shaft in the headstock. It's all the same diameters, but it's 24 mil, 25 mil, 24 mil. Basically, it's the metric version of 1 inch for the bore in here. So I was going for a 3-to-1 ratio from the driver pulley to the driven pulley. And originally, I made this pulley. It's about 3.5 inches in diameter. Made a bushing, fit the main spindle shaft, set screwed so it would lock it in place. And this would have gave me my 3-to-1. This would have gave me my 3-to-1 drive ratio. And for whatever reason, I didn't think about it, but this particular pulley does not fit in the headstock of the machine. It's too big, doesn't clear the casting. So I had to go to plan B, which was the pulley that I showed you that's currently in place right now. So that it's about a 2.5, 2 3/4 to 1 ratio that I went with to fit it inside the headstock of this machine. So also this is the original, there's 2 of these. This is the original bearing that came out of the headstock of the machine. Now, there was nothing wrong with these bearings, they still worked, but because I had it all apart, I wanted to change it and put a better quality bearing in there. You know, I didn't want to have to put it all together and then run it and then it failed and then have to do it all again. So this is one of the original bearings. Like I said, that came out of the machine. I replaced it with a bearing from this manufacturer. Same numbers, better quality bearing. There's 2 of them. So there's one in the front of the spindle, one in the rear of the spindle. Then I machined riser blocks because the stock version of this machine is only a 10-inch swing by 18-inch long usable length and diameter. And I wanted to be able to swing a bigger part. So I machined 3-inch riser blocks out of aluminum. There's a video on my channel that shows this riser block actually being made. This one is basically the same process, but it's hollow in the center so that it's got clearance for the pulley to run through it. They're made out of aluminum with some extra stock drops that I had laying around. I'd been saving for quite some time, and this is the perfect opportunity to use them. So I machined 3-inch riser blocks out of aluminum, mounted on the machine, and now I have 8 inches from center of the spindle to the top of the weight, which gives me a total of 16-inch swing, which is a much larger bowl than what this machine and frame was actually designed to be able to swing. So I haven't gone that big yet. I just put out a video the other day that showed me finish turning the bowl that actually burnt my old motor up. So like I said, there's just going to be a quick video of what I did, how I did it, and I'll put out another video on my normal schedule. It should be Sunday morning, should be my publish date, of me making something else. I don't know what I'm going to do yet. I never know what I'm going to do. I just kind of wing it, and I put the stock up there, and I just go for it. Whatever happens, happens. So anyway, I haven't tried the full swing capacity of the machine yet, but knowing that this machine was really shaky when I only had a 10-inch diameter part in here, the frame was real lightweight, the casting's real lightweight, and it would kind of scoot all over the floor. I'd have to chase it around. Now, I can mount it to the floor, but I don't want to put any holes in the floor in my basement, so I explored another avenue to take care of that issue. So I did add, currently it's about 160 pounds to the frame of this machine. They're weights that I mounted to the legs of the machine. There's two weights per leg of each machine, and the total weight that they accumulate is about 160 pounds. So this is really friggin' heavy now. It's hard to move around. I think it's going to work out much better. I also have a steel plate to replace the top of this with, and it's another 60 pounds. I'm only going to put that plate on here if the weight that I've added to the frame is not adequate enough to keep the machine from jumping all over the place. So we'll see what happens after I use it for a little while. So back to the lathe. So this is the original switch that comes with the machine. Still using that. There's plenty of videos online that show people how to convert their machines from an AC motor to a DC treadmill motor. And, you know, I watch those to figure out how to do it. And there's a particular creator online right now that has excellent videos, and I would recommend going to his YouTube channel and from there going to his website and watching what this guy does. You got questions on how to do stuff like this, he's got the answers. The name of his YouTube channel is Days Cars, and I'm going to say real quick thank you to Days Cars for answering my questions and putting out those awesome videos. I really do appreciate it. Anyway, so let's see what else. The locking mechanism for the tailstock. The original one is only about 3/4 inch diameter, and it's about a 3/8 stud. So that had to be remachined for this to account for the extra torque that was going to be pushing back on it. So now it's a 1 inch shaft that goes down through here, and the same. Basically, I just beefed everything up. It's the same as what the stock is. It's just much bigger, much heavier duty. So let's see, what else can I tell you about it? I painted it. All the videos online. I've never seen one this particular color, and I liked it, so that's what I went with. I wanted it to be different, and that's the way it is. So anyway, I guess I can turn it on real quick for you, show everybody that it does work, let you hear the sound that it makes, and then we're going to sign off, because that's pretty much it. I don't want to go into showing the electronics of the SCR controller that I used with the potentiometer that I'm using to regulate and control the speed and the RPMs, because I'm not an electrician. I don't want anybody to use my video to build their own lathe setup. I'd rather look at somebody else's work and do that, because really I don't know what I'm doing electronically. I just kind of fumble my way through it. So anyway, I'll fire it up and give it a run, and then that's gonna be it. So we hit the power switch here. LED light comes on, lets you know that there is power going to the entire machine, because it's not making any noise, and it'd be real easy to grab a wire not thinking that it's on, and it's on. So power's on. Give the potentiometer a little turn, and the motor comes right on. It'll spin right up. I'm not going to crank it wide open. There's no point in doing that. And there we go. Turn it off, power's gone. The only thing that I haven't made yet is a new banjo. I'm currently in the process of machining a new banjo to accommodate the new diameter that this machine will swing, because as it stands, this banjo is only made for a 10-inch max diameter bowl or object. I need one that'll be able to get around a 16-inch diameter, and this one ain't going to do it. It'll work for now until I get the new banjo completed. Once I get that completed, I'll mount it to the machine, paint it the same color. I'll show everybody, and we'll go from there. We'll just continue to make some videos and see how well this little mini lathe does for making bigger lathes, full-size lathe parts. Okay, that's all I got. You got any questions? Put them in the comments. I'll do whatever I can to answer them as best as I can. And if you like what you've seen, maybe subscribe, maybe even drop a like, and we'll go from there. So thanks for watching.